Here is an explanation for the answer to final exam question number 80 in Alternative Energy Demystified, 2nd edition. If you have the printed book, you'll find it on pages 328 and 329. We're talking here about a spaceship that uses a solar sail. Well, what is a solar sail? That is something that takes advantage of the solar wind, that is the high-speed subatomic particles that constantly stream out from the sun, to actually navigate through interplanetary space in much the same way as an old sailing ship on the sea used to do with the real wind on the surface of the Earth, the motion of the air molecules. The high-speed subatomic particles from the sun actually produce a certain amount of force. So, what might affect this? Interstellar nebulae? Well, not really, because they're too far away. They have nothing to do with the solar system and interplanetary space amongst the neighborhood of our own sun. Irregularities in the fission process. Well, there is no fission process in a solar sail ship. In fact, it doesn't even need an engine per se. It's actually like an old sailing vessel. It'd be kind of nice to have a backup engine, though, to do some fine maneuvering when necessary. How about ultraviolet radiation from the sun? Well, not really. It would have to be an incredibly intense burst of visible or ultraviolet radiation to have an effect on a solar sail vessel. What really affects it is the solar wind, the heavier subatomic particles that are ejected from the sun. So it's certainly not any of the above. E. What about C? Intense magnetic fields near certain planets. Jupiter and Saturn would be good examples, the best examples. Well, yes, that can affect the course or motion of a solar sail ship because it affects the direction of the solar wind. These are charged subatomic particles, and when they approach a magnetic field, even the one around the Earth, these charged particles change direction. They tend to focus towards the poles of the planetary magnet, in much the same way as iron filings would focus towards the poles of a bar magnet. So if you come too close to a planet like Jupiter or Saturn, besides having to deal with the gravitational effects, which would probably be considerably greater, the intense magnetic fields will cause these solar particles to change direction, so the wind changes direction, and it'd be like sort of like a little storm. You'd have to adjust your solar sail vessel in order to deal with that kind of a situation. Here's a drawing of a solar sail vessel. The solar wind, the subatomic particles come at the big, flat, lightweight thingy. It would probably be something made of very lightweight, high-tech material that can withstand the rigors of interplanetary space. The force reflects the particles in much the same way as a conventional ship's sail would reflect or deflect the air molecules. So you get a propulsion force in a direction like that. So once again, the correct choice here is C. Magnetic fields around planets can, in fact, affect the course of a vessel like this because they affect the direction of the solar wind.